in order to kind of understand logarithms, the first thing that we have to know is, even though it seems really abstract, it's actually pretty useful. Logarithms are just a notation, just a way of writing numbers in a different way. So do you guys remember when we did scientific notation back in Algebra 1, pre-algebra? Okay, so if I gave you a number like 1,630,000, how would I write that in scientific notation? 1.63 times 10 to the 1, 2, 3, 4, 5, 6, right? Okay, now does everybody agree that these two numbers are exactly the same? I'm just rewriting it in a different way, right? Okay, logarithms, what we're doing from now on is just taking exponential functions and equations and rewriting them in a different way. So an example of an exponential function, 2 to the third, which is equal to what? 8, right? This is an exponential equation. We have a base, we have an exponent, and we have our answer, right? Yes. Another example of an exponential equation, 3 to the x equals 12. Is this an exponential equation? Yeah, we have a base, we have an exponent, we have our answer, right? Okay, so the exponent can be a variable, and we will see that. Today we're not working with exponents that are variables. But the reason why we have logarithms is so that we can work when the exponent is a variable. So all logarithms is a different way of writing these types of numbers. That's it. It's just a notation. Okay? So let's look at it. What does the notation look like? Okay, here's our exponential equation. We have n equals b to the p. That's something that we've already seen before, right? If we want to write it as a logarithm, we would take our exponent, and that becomes our answer. We read this p equals log base b, because the base of the logarithm, is the base in the exponential equation. So log base b of n. Ends up being your answer from the exponential. Okay? We're usually going to see it written log base b of n equals p. Usually the equal sign is going to be on the right-hand side. And a little trick that I do to convert from logs to exponents is we always start at our base, and we go up and around and end up in the at our answer. So this would be b. What's on the other side of the equal sign going around? P, so that's your exponent, is equal to wherever you land, n. So that's what I do. I have it, and I go, my math teacher when I was in Algebra 2 used to call it going around the horn. And I'm not exactly sure why she said that. Second period thinks that this looks like a horn, like a ram's horn or something. I don't know. I don't know. So my teacher used to call it going around the horn. I think she was thinking cape horn.
Cape horn?
Cape horn. It's a cape, and way back when in order to get around it, you have to sail around the cape.
Oh, Cape Horn.
Cape Horn.
Cape Horn. Like
it's named after a person.
Oh,
yes.
okay.
Okay. So what you do is you start at your base. You just go around and rewrite it this way. So whatever we hit, that's our exponent, and where we land, that's what our equal sign is. So that's how we convert. Okay? So all we're going to be doing today is converting from exponential to logarithm, and from logarithm to exponential. That's all we're doing today, is just getting used to the notation and converting back and forth. Okay? So looking at our example, if I have log base 5 of 125 equals 3. Right now, let's just rewrite it as an exponential equation. So I start at 5, that's my base. When I come around, it hits the 3, so we raise it to the 3. And we end up at 125, so equals 125. And we should get a true statement. Is this a true statement?
Yes.
Yes, so it's all good. Okay, so of this, what's the base of this logarithm? 5 is the base, which is why when we read it, we read log base 5. And that's the base of the exponent, right? So the base of the logarithm is the same as the base of the exponent. What's the exponent here? 3. The exponent is 3. So whatever our logarithm is equal to, That's our exponent. So all we're doing in our examples today is identifying the base and then rewriting as an exponential equation. And what we need to do is, as we're doing this, we need to make sure that we get true statements. On your homework tonight, you're going to be asked to verify if the statement is true or not. Okay, all of the ones that we're doing today are true, but we'll double check anyway. So for these examples, we just want to name the base, and we want to rewrite the equation. Okay, so let's start with number 1. What's the base in number 1?
6.
The base is 6. Okay, this guy right here. So to rewrite it, I start at 6, raise it to the 3rd, and it's equal to 216. Is that true? Yes, it is. Okay. Same thing for number 2. Base is 4. So we start at 4, raise it to the 4th, and it's equal to 256. Also a true statement, yes? It is. It is. We did it in second period. Okay. Number 3. Base is 5. And rewriting it as an exponent, 5 to the 0 is equal to 1. True? Yes. Yep. Okay. Number 4. What is the base here? The base is 2. There's a typo. So we start at 2, raise it to the -2, and it should equal 1/4. Is that true? Yes. Okay, you guys see where we're going here? Okay, now there is a typo. I have 2 4s. It should be 5. We should have 8 problems. So let's change that really quick. This is number 5. This is number 6. Then we have 7 and 8. Okay? So what I want you all to do is I want you to do 5 through 8 on your own, but look at number 5 really quickly. We have log of 0.001. There's no base there. For logarithms, if it just says log and they don't give you a base, the base is actually 10. Okay, now why is it 10? Well, our numbers are base 10, right? We always start over after 10. That's why for logs, if we don't write it, we just automatically assume a base 10. And we'll do more practice with that. But just for number 5, for this one, just write in a 10 right there. And give me the base and exponential equation of the last 4. Okay. Okay, double check yours. Is that what you all got? Yep, so all we had to do for each of these was you start at your base, remember, and then for some reason my teacher called it around the horn. So we just go all the way around.
Wait, why is that base 10? Are you kidding me?
All we're doing today is converting back and forth from exponential functions to logs. We're just getting used to writing it back and forth. So, yeah, that's it for today.